Today's topic is performing DFT of two sequences at a time. So, say for example, we need to find DFT of GN and HN two signals at a time. That means by only computing endpoint DFT, we will be able to find DFT of GN and HN separately. So how do we do that? First of all, we have to get a sequence which is Gn plus J of Hn. That means we are intentionally making a complex sequence which is Xn, which will be equal to Gn plus J of Hn. Now, from here we can write Gn will be equal to Xn plus X star n by 2 and Hn will be equal to Xn minus X star n by 2. X star n is complex conjugate of Xn. This we all know by the knowledge of basic mathematics. So xk, as the formula is equal to summation n going from 0 to n minus 1 x of n wn to the power kn, where k goes from 0 to n minus 1, capital N minus 1. So now if we take DFT of x star of n, that is the complex conjugate of xn, then the same here again the limits of summation are not shown because these are the repetitions. So x star n wn to the power n k. So we can write this as summation x of n wn to the power minus nk whole conjugate, whole to the power star. Here we have changed the polarity of wn, that is the power of wn, we have made negative because wn, if we remember, is actually e to the power minus j twice pi by n. So we have taken a negative sign. So again when we give a conjugate, we take the conjugate of wn to the power minus nk, it becomes positive, that is wn to the power plus nk. So these two things are the same but different ways of writing. So this can be written as x capital X star of minus k modulus n. Now as it is whole to the power star, so instead of writing x of k, capital X of k, we can write capital X star of k. But here we see in the power of wn there is minus k into n. That is, we have to write capital X star minus k. Now if we are writing minus k is again out of our range of vision. So we have to bring a modulus n here, modulus of capital N. So we can say that DFT of small x star of n is capital X star minus k modulus n. Carefully note the different steps of mathematics we have done here. So capital GK by superposition, or we can say as it follows, DFT follows linearity property. So capital G of k can be written as half of capital X of k plus X star minus k modulus n. See, in the previous slide we have shown Gn is equal to half of Xn plus X star n. So if we take DFT on both the sides, then capital G of k will be equal to half of capital Xk plus the DFT of X star n, which we have shown as capital X star of minus k modulus n. Similarly, h of k will be 1 by twice j xk minus x star minus k modulus n. We have taken again two examples, that is Gn is equal to 1201 and Hn is equal to 2211. Now we will find the DFT of both the sequences, but by computing n-point DFT only one time. And we will verify the answer with the answer that we have got previously while solving circular convolution. Now, as mentioned earlier, we have to take a complex conjugate sequence by adding Gn and Hn. So, the complex conjugate sequence here that we get is xn is equal to 1 plus twice j, 2 plus twice j, j and 1 plus j. And we already know W4 is equal to minus of j. We solve this DFT by the matrix method of solving DFT as I have discussed earlier. Here capital X of k is equal to the x of small x of 0, small x of 1 is mentioned here in the column matrix, and the dimension matrix, as I told you, the first column and first row of the dimension matrix will be always 1. All the components of the first row and first column of the dimension matrix will be 1. So, and all the other twiddle factors are found out and written here, because the second component of the second row will be W4, which is minus j. In this fashion, we have filled up the whole dimension matrix. And by multiplication, we have found out xk as 4 plus 6j, 2 minus 2 and twice j. So now we also have to find out x star minus k modulus n. So before that, we have to find out x star k. Now x star k will be the complex conjugate of xk, that is 4 minus 6j, 2 minus 2 and minus 2j. So from x star of plus k, we can find x star of minus k modulus 4. Whenever we give a minus k, that means we take it out of the range. To bring it back to the range, we add a modulus n. In our case, the modulus, that is the length of the signal that we have taken, is 4. So here n will be, the modulus will be 4, which is equal to x star 4 minus k. So if we now change k is equal to 0, k is equal to 0 means x star 4. That means x star 4, again you have to subtract the modulus 4 here. So that means x star 0 is the same, that is 4 minus 6j. Now x star when k is 1, that is x star of minus 1 modulus 4. That means we have to add 4, that is x star of 3. X star of 3 was minus 2j. So here minus 2j comes in position of x star minus 1 modulus 4. Now x star minus 2 modulus 4, that is 4 minus 2, 2. X star of 2. X star of 2 is minus 2. So minus 2 comes in this position. Now again x star of minus 3. Minus 3 is again out of our range, so we add back plus 4, that is x star of 1. X star of 1 was 2. So here 2 comes in the position of x star of minus 3 modulus 4. So this is our x star minus k modulus 4. So by this gk and hk formula, we can find out the gk and hk here, and we can match it with the previously found answer, which exactly matches the result. So it has been so here we have done two things. We have found out the DFT of two sequences by doing n-point DFT only one time, and also we have solved the DFT of sequence using the dimension matrix method. So class, let me end the class today and the topic here, and we will proceed with the other topics of DFT in the next class. Thank you.